You'll see in a minute, 25th. Okay, so the title is on the board, and I'm just waiting for a little red bit to come around the edge. Yes, that's a red bit, so it's working at home. So if everybody could copy out today's date, which is the 25th of September, this is our first lesson on arithmetic sequences. And we're going to start off with a whole bunch of different sequences. These aren't necessarily arithmetic. So please can you just copy down numbers 1, 2, 3, 4 and 5. If you can try and leave a bit of a blank to the right, you'll see that I'm going to expose a couple of learning points in a minute. So just if you could do it like I've done it on the board, can you just try and guess what the next couple of numbers are, but don't take up the whole of the width of the page, please. Okay. So just by looking at the patterns, can you try and decide what you think is going on? And the first two are the same sort of idea. The others, I'm just going to see if you can spot them, because there are all different types of sequences. So I've done the first couple for you, and you can see all that's going on there. We're just adding on 2 each time to get our 9 and 11. And on the second one, you can see that we're taking away 3 each time to get 11 and 8. Numbers 3, 4 and 5 are different. We're not just adding or subtracting. So just see what you think is going on there. See if you can spot the pattern. I'll be hugely impressed if anybody can get number 5. Do you? Wow. So Poppy knows. Well, we'll see. We'll see if you can spot it. It's also very famous. It's named after a famous mathematician. Let's see if we can. Think squares.
Yeah. I didn't know what's next. Because I did, I've never been to Oh, I put it in.
Okay, what do you think, Henry, for number 3? What do you think is going on to get the next number each time?
Don't you double it?
Good. We are doubling each time. So 2 times 2 gives us 4. We're doubling it. We're timesing by 2. So to get the next number, 2 lots of 16 is 32. That's a 3, sorry, 32. Then 2 lots of 32 is 64. For what it's worth, that's called a geometric sequence when we double or we times by 3 or something to get the next one. What about number 4? Did anybody spot that before I gave you the clue? No, that's all right. So what do you think that one is, Grace? What's going on? Yeah, good. What's happening there? It's all the squared numbers. So 1 squared is 1. 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 32. So the next 2 are 49, and that's what 7 7s are, and 8 8s are 64. So we were squaring to get the next one. Right, Poppy, amaze us. Yeah. Go on, what's the pattern? Well done. That's really well spotted. What was saying? Let me just watch you. You're given the 2 ones to start with. What's 1 add 1 flow? That's where the 2 comes from. What's 1 add 2? That's where the 3 comes from. What's 2 add 3? What's 5 add 3? What's 5 add 8?
13.
Okay, and what's 8 and 13?
21.
And what's 21 add 13? Yeah. Now that is called the Fibonacci sequence. Fibonacci, and it's really, really cool. When we've got some spare time at the end of the year sometime, we'll have a look at Fibonacci, and it's amazing how much in nature automatically follows that sequence. It's spooky. So if you were doing like poppy seeds, as you come out of a, sunflower seeds, you'll get 5 in a circle, then 8, then 13, then 21, then 34. It's spooky how in nature Fibonacci is copied. That's right, absolutely. It's like a shell, absolutely right. Okay, good knowledge. So, what we're going to be doing today, can you write this down, please? Those first 2 there, so just copy that down, please. It's quite small, so I'll read it out to you. Write these next 2 sequences 1 and 2. These first 2 are called arithmetic sequences, where we add or subtract the same amount each time to get the next term. So as we saw, we added 2 each time on number 1. So you can copy this down, please, Henry. And then on number 2, we were subtracting 3 each time. So just to read it for those of you who are struggling to see that, it's quite small and blurred on the board. These first 2 are called arithmetic sequences, where we add or subtract the same amount each time to get the next term. And you can tell from the title of today's lesson, that's where we're going to be spending our time. Okay, they might look the easiest, but maybe they are, but we can do some really cool stuff with them. So these first 2 are called arithmetic sequences, underlined, where we add or subtract the same amount each time to get the next term. And you can write that down or not, I don't mind. But today's lesson, we're going to be focusing on arithmetic sequences, hence the title of the lesson. Now, just a couple of still writing, that's fine. I can't see you writing, Cecily, or you. It's no, you did, that's fine. Okay. So, so these first 2 are called arithmetic sequences, where we add or subtract the same amount each time to get the next term. No need to write the bit in red. Now, what you're going to have to get familiar with is what this n business is all around. You won't know what I'm talking about yet, but I want to introduce you to n. So can you do a subtitle, please, called Introducing n? This is going to be really important to understand. You're going to need to understand the difference between what n is and the number itself. Now, this is key. Yes. So the key bit, and if you could just underline it, n represents the position of the number in the sequence. So if we had Grace, Poppy and Flo lining up for lunch in that order, Grace is number 1, Poppy's position number 2, and Flo's position number 3. It's literally where they are positioned, okay? It's your position in the line. So say Poppy has got a number 8 written on her. She's 8, but she's in position number 1. She is when n equals 1, okay? So n is the position of the number in the sequence. And I just want to do a few examples just to really reinforce that. So on the left-hand side, can you just copy down that first sequence, please? So the first sequence, 3, 5, 7, 9, 11. And I just want you to just understand what's going on. So the 3, that is obviously first in the queue, isn't it? Okay, that's when n equals 1. Right, 5 is second in the queue, so that's when n equals 2. 7 is when n equals 3. 9 is when n equals 4. 11 equals n equals 5. So for the 100th term in the sequence, say what we just carried on doing that for ages, we don't know what the 100th term is, but it would be position number 100, so it would be when n equals 100. Okay, so for number 2, copy out number 2. So what is n for the 14? Just what is n for the 14? I want you to write down. So what do we know about n for the number 14 there? Hands up if you think you know. Flo. As simple as that. It is as simple as that. So what is n for the 14? That is when n equals 4. It's fourth in line. For that second sequence, the 14 is when n equals 4. It's position number 4. Simple as that. So you don't have to write all these down. See if you can just sort of write a few down until you get it. So Henry, what can you tell me about that 6 for number 3?
6.
Yeah, that's when n equals what?
N equals 2.
Yeah, it's excellent. Yeah, exactly. So for that 6, for the 6, n equals 2. It's just second in the queue. Simple as that. Okay, it's as simple as that. Lucy, for that last one, what can you tell me about n for the minus 2? Yeah, simple as that. Absolutely. So for the minus 2, n equals 3. So you won't quite understand why I'm making a big deal about that at the moment, but that's going to be really important shortly. So you've got to be really clear in your minds, okay? N is the position, but it's not the number, okay? For that, the one that I can't remember. You just told me that last one. I forgot who it was, right? Yeah. So for the last one, n's 3, but the number isn't 3, is it? The number is minus 2, but because it's position number 3 in the queue, okay, it's the minus 2. Okay. So it doesn't matter if you haven't written down all of those, okay? If you're watching at home or you're watching on the video, you can obviously pause the video and then just write them all down after the lesson if you want. But n is simply the position. Cool. Now, here we go. This is the first question we're going to do. All right. So we're going to be looking at the sequence 5, 7, 9, 11. So what's going on with that sequence, Cecily? No, but what's going on? Just forget the questions. What's going on with 5, 7, 9, 11? What's clearly going on? With plus 2 each time. Now, can you go and write down the questions 1, 2, and 3? So can you find the 7th term in the sequence? That's when n equals 7. And I just expect you to carry on until you get to the 7th one. Don't try and do anything clever. So please copy out the sequence at the top, write out the question in blue, and then please can you just do some workings to go and work out what the 7th term in the sequence is. That's when n equals 7. And can you find the 10th term in the sequence when n equals 10? And then can you find the 100th one, the 1000th one for me, please?
1,000?
Yeah.
Yeah.
Yeah. Just do the first 2 for now. Well, we'll see. Just do the first 2. Just do the first 2 old school. Well, you know, just adding on until you get to the one you need. Make sure you're copying out the question and the answer, please, Henry. Again, just so you're really getting used to what n's all about, can you write those positions above, please? So what's your answer for the first one? Yeah, well, no, the number 7, yeah. So find the 7th term in this sequence. Well, that's easy. We just carried on adding 2 on. And we've got to 17 pips. Absolutely easy. Okay, and find the 10th term. That's no big deal. We'll just carry on a bit. So the answer is 23. And then if you could just start doing the third one, please. Come on, Grace. Go on, honey. That's all right. Cecily, have you finished the third one yet? Okay, cool.
I know what it is.
What do you reckon it is? Go on then, you said you know what it is. Go on, Henry.
2,300.
2,300, okay. Cecily? Have you written them all out yet? Yeah, no. Dan, have you written them all out yet? Well, why not? That's pretty naughty. I'm kidding, Dan, I'm kidding. No, good. Let me just start. No, look, what's been really good, all of you, Grace immediately said you are having a laugh, sir. And she says, no way I'm writing out 1,000 numbers. And Cecily and Dan and lots of the others of you, I should have said 10,000, but 1,000. You've all thought, look, it's daft. There's going to be absolutely no way that you're going to expect us to write those out. We are going to need to find a shortcut to do it. And maybe Cecily got it right, maybe Henry got it right, maybe Dan would have got it right. But I'm going to show you a way that stops you having to write out the longhand. You all know you could do it. You all know the strategy. You just keep on going with that list, wouldn't you? And okay, say I asked you to work out the 1,000. How long do you think that would take you? The day? 5 minutes. That would take you all day, wouldn't it? But say I asked you to work out the million. That's going to take you a year. Okay? Yeah. So we need to have a strategy. We need to have a strategy to work this out. So can you just go and write down, so we're just clear where we're coming from. Well, just write out the question, please, Grace. But then we're not going to answer it. So can you just write underneath this one? Clearly, this would take a long time. So we're not saying it's impossible. It's easy. It would just be hugely time consuming. Okay. Clearly, this would take a long time. Is it a long? It's about A-L-O-N-G, or is it a long as in two different words? A long. Two words. No, it's definitely not David. I think in this context it is a long time. But we're not going along the road, are we? This is taking a long time. Clearly this would take a long time. Okay, quiet please. So we need another way to work this out. And this is what I'm going to teach you. Now, Cecily and Henry and Dan all thought they might have a strategy. I'm going to teach you a method, and it'll be interesting. You can check whether your strategy would have got you the same answer. So to find the 1,000th term in this sequence, in other words, when n is 1,000, we know exactly what we would do. We go 23, 25, 27, 29, 31, 33, and so on until we had 1,000 numbers in that row, and the 1,000th number would be our answer. Okay, so let's go and write out. So what we're going to do. Okay, we're just going to. I'm going to show you how to do it. So I'll just give you an opportunity to have got that copied down. So all I want you to understand is you don't have to do it the way I'm just going to show you. All of you guys could do this, but it would take you forever. So we need to find a quicker way of doing it. Okay, so it's going to be a 3-step process. All I've done there is the same slide. I've just given myself a bit more space. So step 1. So please, if you can color code this as you go, that would be great. The first step is you establish what we're going up in, and we're going up in +2s. We're going up in 2s. So step 1, sorry, we write down 2n. If we're going up in 3s, guess what you would write? 3. Guess if you're going up in 5s, guess what you would write? If you're going down in 3s.
Minus 2n.
Down in 3.
Minus 3n.
Good. Right, now.
Is it?
It's going to be a bit of algebra. Now, We're not going to say anyone's names because it would be really mean and I don't want it to happen. We're going to make it up. I'm going to call it Jimmy. We haven't got a Jimmy. No, but this person's going to be annoying. It's going to be ego. All right. As Grace has volunteered, which, no. Shush. Stop it. Can we just be quiet, please? So, I want you to imagine, because Grace wants to be the annoying person, I want you to imagine that 5, 7, 9, and 11 are all queuing up for the lunch. Okay? What position is number 5 in? No. First. Can you write this in? What position is the 7? What position is the 7? What position is the 9? Where are they in the queue for lunch? Third. Dan, where's number 11? He's fourth in the queue. Now, along comes Grace. Annoying child. She pushes into the front. She pushes in there. Now, because she's pushed in front of the n equals 1, we've got no choice but to really call it n equals 0. So can you go and write 0 above it? Because then n's going 0, 1, 2, 3. And what we're going to call this, you're going to have to get used to the idea. Can you do an arrow to the circle that Grace is going to be in? And this is called the 0th term. The 0th term. And it makes sense because it doesn't really exist. It's just the person who's pushed in the front of the queue. They pushed in front of number 1. Now please don't call it out. I want everyone to have a think. What number would Grace be? Don't call it out, but what number would Grace be if she pushed in front to keep that sequence going? So just all have a think. Grace.
3.
Plus 3 or minus 3? Good. So can you all go and put a plus 3 there? And that is our second bit of our expression. So where did the 2 come from? Hands up. Where did the 2 come from? Hands up. Where did the 2 come from? I know you got your hand up on some. Henry, where did the 2 come from? That red 2.
Did it come from the 2n?
Yeah, but where did the 2 come from?
Oh.
Why wasn't it 6 then? Where did the 2 come from?
Because...
Look at the sequence. Where did the 2 come from?
Because the sequence is like 2.
Good. So the 2 came from... Please listen, everyone. Please listen. The 2 came from the sequence. Where did the Grace plus 3 come from? Hands up. Where did the plus 3 come from? It was the 0th term. It's the person who pushed in. Now, this is the cool bit, guys. You're going to love this.
Yay!
Because we're working at the 1000th term, what is n? What is n? I'll give you a big clue. Good. So we go and take that 1000 and we plonk it into this expression. What does 2n mean? Poppy. Good. So we're going to do 2 times 1000, and then we're going to add on 3. What's 2 times 1000?
2000.
And then adding on 3.
2003.
So what we are saying, the answer is 2003.
I was the closest, sir.
Yeah, you're close. Right. Hands up if you can tell me what the millionth term would be.
2 million.
Good.
What
What would be the billionth term?
2 billion 3.
Look how powerful that expression is. So, step 1, you work out the red bit. Step 2, you work out the Grace. And step 3, if you're working out the 1000th term, you put 1000 into the expression. If you're working out the 50th term, you would put 50 into the expression. N is the position. Right, so you have a go on this one, please. So just follow the example we've just done. I want you to find the 50th term in this expression. Go. So just do the bits like we just did. So take your time, look back at the one you've just done. So take your time. I'm just going to move it across a bit to give a bit of space for Grace to push in. So, but just do it step by step. Remember, Grace isn't the first step. There was a red step first. Look back. Well, mine was red. What was where did the 2n come from the past? So just don't call it out, but just do it step by step. So you need to get that red bit first. So take your time. It's going to be a 3-step process. Okay, you've all got it. I'm just going back to the last one. Hang on, you worked out the red bit, then you worked out the blue bit, and then you popped 1,000 into that expression. So you need to look back at your notes. I'll show. I'm just going back to the last one because Henry raises a good point. Grace went and pushed into the front.
Yeah.
And can you see, because we're going up by 2 as we go to the right,
Yeah.
to keep that sequence going, Grace would have to be 3, so that the sequence is 3, 5, 7, 9.
But what n is Grace and n2?
Don't worry about that. It's all right. It'll take you a while. Just do your best. Just do your best. So step 1, try and do that red bit. Step 2, adjust the expression with that 0th term. And then step 3, try and use that expression. No, just give it a go. Don't call it out, Cecily. I want everyone to think. I don't expect hardly any of you to be able to get this right straight away. But yeah. Hang on, or something. Yeah. If you're going up in 2s, it would be 2n. If you're going up in 4s, it would be 4n. So remember where that 2 came on the last equation.
Could you go back?
Yeah, I'll go back just to remind you all. You should have written it down at the time. Okay, all right, thank you, Flo. So we're going up in, shush please. We're going up in 2s last time. So our starting point was to write down 2n. We then go back and work out the 0th term. Imagine someone pushing into the front. What number would they have to be for the sequence to work? And then step 3, when we were working out the 1,000th term, we popped 1,000 into the expression. We're not working out the thousands this time. Okay, here we go. All right, that's fine. Please. The thing is this won't take long if you're getting it right. I just didn't want you all floundering. Okay, I wanted you to just be quiet, please. Come on. So step 1, what are we going up in? And just pop an n after that. Step 2, you go and add on another bit or take away another bit onto that expression with that bit in blue last time. And step 3, you go and find out what you need to find out. You shouldn't be putting 1,000 in this time because I haven't asked you to work out the 1,000th term. I'm not going to tell you. We're going to go over it in a sec. Right, good, we're going. So again, I think color coding is nice. We're going up in 3s. So our first step should be to write down plus 3n or 3n. Of course you do. You then need to go and work out the grace, that annoying person is pushing in. Now, this is to be careful, because we're going up in 3s, left to right, to keep the sequence going, we need this to be a plus 3. So that would be a plus 4, because 4 add 3 is 7. Now, somebody said last time, does that mean all the n's change? No, it doesn't. Yeah, no, because grace doesn't actually exist. All right, it's just a theoretical 0th term. Okay, a 7 is still the genuine first term. 10 is genuinely the second term. That plus 4 is just really an adjustment we need to make. So it's not really there. It's the 0th term. It's it's just ghostly, if you like. Now, that is the expression we're going to use. Because we're working out the 50th term, that is when n equals 50. So we pop 50 into our expression. 3 times 50, and then once we've done that, we add on 4. 3 times 50 is 150. You add 4, we get 154.
Let's go! I got that right. Come on! I think my answer was... Okay,
next one. Let's get on with the work, please, guys. Thank you. Questions on the board, Henry? I'm not telling you. Now you've got to think. Look back at it once you're done. Shush, please. Okay, right, out of interest, Henry, what answer have you got? I'm not telling you if it's right or wrong. I'm not going to go yet. 157, anyone disagree? Oh, anyone agree? Oh, right. Henry, looks like you might have got it right. Sorry if I sounded a bit surprised. We will see, I'm not saying it's right yet. Never. Right, who's still going? Who needs a bit more time? We will see.
I've already got that.
Okay. So step one, we see how much we're going up in or down. And we're going up, well, we'll see, we're going up in fours. So because we're going up in fours, step one, you write down 4n. You then, I guess we can stop that. You then adjust for the 0th term. Now we're going up in fours. So if we go back from +1, we get a -3 adjustment. Did you all get -3?
Yes.
Now, because we're working out the 40th term, n is 40, so we put 40 in there, 4 times 40, and then we take away 3. So we get 160, take away 3, which is 157. Is that what you said, Henry?
Yeah, I said that. That's what I... For the red thing.
Well, plussing a -3 is minusing a 3.
Okay.
Okay, very well done. Now, I'm going to put on a stinker now. You're going to have to really think, really think. Right, go.
Anyway.
Right, can we just do this in silence, please, so we're not disturbing those working at home? Now you're going to have to think. You're really going to have to think here.
Where's where you go?
Should I? Don't call it out, Henry. Never ever call out the answers when other people are gathering their thoughts. There's no dividing involved. When we were going up in threes, we did 3n. You can. I'm not going to tell you if it's right or wrong because I don't know, but we'll wait until other people have got answers and then we'll see. We can make a note of what people's answers were. It's exactly, Henry was right, it's exactly the same strategy, but you've just got to be ever so careful with your signs. Right, so Cecily, do you want to volunteer a final answer? 112, so you think even though the numbers are going downwards, your final answer has magically gone upwards. That's interesting. Grace? Wow, so even though the numbers are going downwards, you've still managed to end up with a positive number. That's fascinating. How can they be going down and you end up with something bigger? Well, we'll see. Dan, what do you reckon? We'll see. We'll see. I don't know. Right. Okay. At least those minuses.
That's what I got.
Just listen. At least they might be right. Look, you can see the sequence we're going down. The final answer can't be bigger than those numbers, can it? So let's just go through it methodically. We are going down in twos. We're going down in twos. So our starting point should be minus 2n. Now, what is the annoying Grace number here? Good, it is 62. Of course it is. You can see we're going, if you're going right to left, we're going up in twos. Is that a plus 62 or a minus 62? Yeah. So we're working out the 100th term, so n equals 100. So pop 100 into our expression, minus 2 times 100, and whatever we get there, we're going to add on 62. So we've got minus 200, adding on 62, and I think that's minus 138.
Let's go.
So what you had? Yeah. Think, oh no, is that bad math? 6 minutes. Number line flow. If you're on flow, can we silence?
Oh, I got that.
Flow, if you picture yourself on a number line on minus 200, and we're going to add 62, what are we moving to the left or the right? Well, you should know. Pardon? Yeah. So, right, no, don't be silly when we haven't fully got. No, who got that one right?
Me.
Did you?
Well, I got half right.
Well, that's not right. Look, right. Flo, it's not good enough to say I've never understood number lines. It's not good enough. So can we just picture ourselves on minus 200 and then we're adding 62 to that. It takes us 62 in that direction. and I think that takes us to minus 138. If we were taking away 62, Flo, then absolutely we'd have gone to minus 262. Do you see?
Yeah.
Right. I think, because it's 3 minutes past and this lesson finishes and we'll be going at 10 past and I want to have time to wipe down the desk and all that sort of stuff, we'll stop there. Next lesson, we will start off practicing some of these trickier ones. Okay? All right, so let's save that.
Is it the end of the lesson?
Not quite. No, you can still, you're just going to sit there quietly and then we know we've still got 6 minutes to go, but I want a bit of time to gather my thoughts and I want to sort of... No, we can't. Right. Lovely. Thank you, Flo. Thank you for telling me.
Yeah. You don't need to, but what we said. No, you just said you don't need to. Well, then.
Oh, you don't need to. I thought you said you do need to. Oh, I don't need to. Excellent.
Excellent, and you
I completely forgot about them. Wait, who's on? Kitty and Nala. Hello, Ralph.
Right, goodbye everyone at home. I'm just about to stop the recording. So goodbye, Gabriella, Kitty, Laura, Phoebe, Ralph, and Sophie.
Oh, bye. Oh, even I knew that. You can't see my beautiful face. How sad is it?